This will be the very first recorded lecture of the trimester, and I'm super grateful that you're able to tune in and listen. You're more than welcome to use this to either reference throughout the rest of the week if you want to remember something we talked about that you didn't get down, or if you weren't here at all, you can use this to catch up so that you're still on track when you come back to class. If you need more time on your assignments, please come and ask me, but this recorded lecture is so that you don't have to be behind if you're missing for something other than just a sickness. So, thanks guys, hopefully you enjoy. To get started on our notes, we're going to want to go all the way over to our Canvas page in our modules. In the Welcome module at the very bottom, you'll see two important things. First is the Note Template PDF, and second is the Note Template Google Doc. If you'd like to print this out and do it by hand, the PDF will probably be best. And if you'd like to do it online and add in your diagrams later, using the Google Doc will be very helpful for you. I'll go ahead and open up the Google Doc now since I'll be doing this online, and you'll see this here. Now, I've already made my own copy. You'll need to make yours in order to edit it. I've named mine Weathering and filled in the top. To fill in the top, it's very self-explanatory. Name with the name, class with the class, and I highly recommend adding your class period at the end. The date when you're doing this, which on Tuesday will be 2/22/22, which is very nice, and the topic, which is weathering. Now, let's go ahead and get into our real notes. This week's topic will be weathering, as you can see, so we're going to need to ask a few questions to really get into weathering. First, we know that things change over time, and that includes pretty much everything. I can't really think of hardly anything that doesn't change over time. The earth changes over time, that's for sure. There are houses here today that weren't there before. There are forests here today that weren't here before. There are species here today that weren't here before. The same is true in reverse. There are plains here where mountains used to be. There are fields here where houses used to be. And there are certainly plenty of species that have gone extinct. So let's talk about that a little bit. How does that happen? We're not going to talk about houses or species, but we can talk about mountains. Sure. Why are mountains here at certain points in history and not here in other points of history? Well, let's talk about how mountains form. All right, let's head over to our whiteboard for that. We've all actually already covered this. So when we have mountains forming, we have two tectonic plates next to each other that are coming towards each other. They're converging, right? Well, when they converge, they either have to go below or above. Mountains form when they go above. So let's draw what would happen if one went above. Well, it would sort of start looking like that, wouldn't it? And if this right here is sea level, check it out. We've got ourselves a little mountain in here. So let's erase all of that and zoom in on our mountain. All right. Just for simplicity's sake, let's start with a triangle. And this mountain has a particular height. And we know also that the plate is still moving. It's still coming up, which means that this mountain is going to get taller, right? We're going to add in blue a layer down here. So this is new, right? This used to be the youngest part of the mountain. Youngest. But now, instead, it's simply younger. The blue part is the newest. It's the youngest. Forgive my writing with the mouse. All right, the youngest. Well, the same is kind of true at the top, right? This is the oldest. But mountains break down over time. So this won't always be the oldest. In fact, eventually it won't exist anymore. So let's say that's the oldest and this is older. But eventually, this part, all in red up here, weathers away. It breaks apart. It gets worn away just by being exposed to nature. And now it can't be the oldest because it doesn't exist anymore. And the part that was simply older is now the oldest. And so we have the same height retained. This is the same height. So like if this was equal to 100 meters, which is way too small for a mountain, but you get the point. This would also be equal to 100 meters. And it doesn't actually shift down. Like the mountain would have gotten taller, but then also gotten shorter at the same time. So it retains the same place in space, which rhymes and is fun. All right. So hopefully that makes sense to you guys. I want you to add this to your notes. There's a whole diagram section. I want you to say, hey, there's an oldest part and an older part, but then it changes. There's a younger part and a youngest part, but then it changes. All right? This is all super important. So mountains form through the tectonic plates, but they are destroyed through weathering. Let's go back to our notes now. So I know I kind of just jumped into an example and I threw around this term weathering. That actually leads us into our big question. So this is the question of the week. Let's go ahead and add that in there. Question of the week. Make it big and bold because it is important. All right, question of the week. What is weathering? If you couldn't tell by our topic, that's what this week is all about. All right, so what is weathering? Let's throw in our definition right now. Obviously, the easiest way to get a definition is going to Google, but I'll go ahead and give it to you. I went to Google for you. I went to your textbook for you. Weathering, the wearing down or breaking down of things exposed to weather and nature. This can be physical or chemical. Now, that raises a few questions already. First of all, there's a difference between physical weathering and chemical weathering, and we'll have to talk about that later. But let's talk about weathering in general real quick. So weathering is wearing down or breaking down because it's exposed to weather and nature. Somebody name one thing that's not exposed to weather and nature. I'll wait. Some of you might be trying to say, oh, the inside of my house. Not really true. Give it enough time. It might not be exposed right now, but your house sure is. It's wearing down, it's breaking down. It's really slow. You might not be able to see it. Maybe you can, but it's happening, which means eventually those walls and ceilings break down. Stuff on the inside, it'll get weathered. All right. So basically everything is experiencing weathering because time is passing. The elements are working on it, breaking it down. But what does that mean, right? For the elements to be breaking it down? Well, let's first add our categories here. We have physical weathering, which I'll underline to make a little category, and chemical weathering. All right. So there's a couple different kinds of physical weathering, and there's a couple different kinds of chemical weathering. And I'm going to go ahead and give these to you guys because I want to give you the building blocks of this information right now, the very beginning of the week, so that you have the rest of the week to explore it yourselves, to write a paragraph or film a news segment or write a poem or make a PowerPoint, whatever it is, but so that you can explore this on your own and tell me about it in whatever way you choose. All right. So physical weathering. This is also sometimes known as mechanical weathering. So let's add that in there. Physical or mechanical. Physical. Physical. What does physical mean? Well, maybe it's easier to start with chemical. Chemical is if you were to change the structure of something, like the atoms, right? The chemicals. So physical would just be not that. Changing, but not chemically. So for example, if I pick up this pen, I have physically changed the location of this object. If I let go of this pen, gravity has physically changed the location of this object. Now, I wasn't breaking that pen down, I was just moving it. But here's the thing. Those were both physical. I acted with a force on this pen. Gravity then acted on this pen with a force. All right? So the same thing can happen, but in terms of breaking things down. So let's start with an easy one. Animals. Animals can break things down. How might animals break things down? For some of you, that might sound like a silly question. They're probably breaking everything that they see because they like chewing on it or swatting at it or clawing at it or whatever. But in terms of nature, in terms of rock and dirt, right? Because those are the things that we're primarily concerned about here. We're talking about mountains, rock and dirt, right? Well, how might animals interact with rock and dirt? They burrow through it. They dig through it. Think of moles or rabbits or a dog digging for a bone, right? So digging or burrowing, super important. That's tearing things apart, breaking them apart, especially if it's rock. That's a huge deal. Or maybe you've seen a woodpecker. They're just slamming their beak against the tree over and over. They're tearing it up. That's a form of weathering. That's part of nature. Animals can be part of this. All right. Well, what's another thing that's alive? Plants. Can plants cause physical weathering? Well, they don't really get up and start smacking things around, but they do move, right? You can plant a seed in the ground and get a tree. Those roots have to go somewhere, and the roots can't occupy the same space as the dirt. And the roots won that battle. It broke apart the dirt. It was one solid piece, and the roots went down there and split it. And now the dirt is further apart. Sometimes that can hold things together. For example, if it's like a sandy hill and a tree is there, well, if the tree dies, the hill's going to fall apart. The roots were stabilizing that. But in other cases, it can go really bad. How many have ever seen a dandelion growing in the sidewalks? Probably most of us. That's going to destroy the sidewalk. It's going to cause it to have all kinds of cracks. And guess what? You get one, it cracks it a little bit more. That causes room for two. Then those two are growing. That causes room for four. Then those four are growing. And that causes room for 16. And it just keeps going. And it's got this like multiplying effect of making room for more. It's pretty bad. It's not great. All right, so plants, roots, split apart, rock, and dirt. You're going to see it a lot. Rock and dirt. Splitting apart rock and dirt is incredibly important to all of this. So let's add another one. What about water? How many of you have ever stood in a river before? The water's moving. I don't want to move. I want to stand in the river. But the water's pushing on me and I can feel it. I might have to lean a certain way or split my feet pretty far apart so I have that wide, stable base, right? So water. Water can push on things. Well, what's the sides and bottoms of a river made of? Rock and dirt. So water can push on rock and dirt. And if you push long enough, you're going to scrape some of that rock and dirt off and pick it up and move it somewhere else. And that happens over a long period of time. That has a pretty big effect. Now, I'm going to say something that might not sound right at first, but trust me. If water can push on rock and dirt, so can air, wind in particular. You ever heard wind chimes? They're moving because of the wind. That makes sense. They're chiming because of the wind, hence wind chimes. All right. Well, in our example of the mountain, it's pretty windy up there at the top. In fact, a lot of mountains are above the clouds. They're peaks. They're above the clouds. So how could it be rain that's tearing down the top of a mountain? It's wind. It's been experiencing all of that water because it started at the base, right? And then it got further and further up. But at the very top, when it finally gives way, finally erodes away, finally weathers away, that's the wind. So the wind pushes on rock and dirt. And if it's weak enough, it'll move. You can test this yourself. Take a handful of sand or really loose dirt and hold it up on a windy day. Let go of it. Does it fall straight to the ground? It gets to the ground, but it goes in the direction of the wind too. You could even test the direction of the wind by doing that little test. And I want to go back to water for a second. Remember how I talked about how plants' roots are splitting the dirt and rock apart and how the water is just pushing on the rock and dirt? Well, what if the water freezes? Have you ever put a water bottle in the freezer? If it was filled up too much, it probably exploded. And if it wasn't and it didn't explode, it looked more full than it actually was. That's because ice is less dense than water. It takes up more space. So if I have, I don't know, a sidewalk with all these cracks in between, and it rains, like it has recently, and then it freezes overnight, like it did recently, it's going to push the sidewalks further apart from each other, won't it? And if it does that one time, okay, no big deal. It's still pretty much where it's supposed to be. And 2 times, no big deal. It's still pretty much close to where it's to be. And 3 times, it's getting a little bit not perfect. Does that 300 times? Sidewalk doesn't look great. So water freezes and expands and splits rock and dirt. It'd be helpful if I could spell correctly. All right. So we have 4 things for physical weathering. If you'd like to do one of your weekly projects on physical weathering and one of them on chemical weathering, I think that'd be a great idea. If you wanted to do one of them on animals and one of them on water, I think that'd be a great idea. But you can use these big categories or these small categories however you want. And if you wanted to find maybe a specific place and talk about all the different kinds of weathering that it's experiencing, perfect. That's awesome too. You can do these projects however you want. All right. But with that said, let's go into chemical weathering. Chemical weathering, I'm going to give a little bit less information with. All right. I'm really only going to give 3 categories. Okay. So first is acid rain. So rain obviously is going to weather things away. That's water falling down and pushing on something, right? But acid rain will dissolve things. It'll chemically alter something. And I'll actually leave that up to you guys to look up what acid rain is, how it's made. Because it is made. It's not a particularly normal thing to happen unless there's like a volcanic eruption. All right? It's becoming more and more frequent. So look into that. So acid rain dissolves things. And that'll be a trend for the next thing, decaying plants and animals. And again, it'd be super helpful if I could spell. All right, decaying plants and animals. It makes sense that plants and animals can split apart rock and dirt if they're alive. We've already covered that. But when they're dead, that makes a little less sense. But you have stomach acid that helps you digest your food. Pretty much every animal does. When plants die, some of the stuff that they decay into isn't too nice to the touch. And it will alter chemically the things around them, particularly rock and dirt. And really anything they come into contact with, but we care here about rock and dirt. So it dissolves things once again. And finally, we have oxidation. Now, this is not about dissolving things, but it is still very important. And you have experienced this very personally. Almost certainly all of you. Oxidation is just a fancy word for rusting. I'll put that in quotes so that you know it's like the same as. All right. This is when iron, which is in most metals that we use, like stuff in your cars, meets oxygen, hence oxidation. They combine and they form rust. That's just what the material is called. That orange, red, bumpy, don't touch it or you'll get tetanus kind of stuff. That's rust. That's oxidation. And you know how it chews those holes in your car? It can do that to iron in the ground too. So say there's a deposit of iron down below the ground, and then a plant grows on top of it and splits apart all of this rock and dirt, and then the plant dies, and now all of this rock and dirt is loose, and Then the rain comes and washes it away, and the iron is exposed, and it experiences oxidation, and now all of it rusts away, and there's just this massive hole in the ground because of weathering. So now you can see what a big effect it can have when all of these things come together and work together to basically destroy something. Which we should also add here, weathering is always destructive. So if you have the diagram of the mountain building and destroying, and you have all of these notes, you should be ready with enough information to start your projects on your own. You can look some of this stuff up and look further. Take learning into your own hands. Go as deep or as shallow as you want, but it's on you guys. I'm going to be going around and talking to you and maybe bringing up some good points to the whole class. And by the way, if I'm bringing something up to the whole class, it's a good idea to write it down because it might be on your quiz. But you guys, in your own research, are going to be partially determining what's on that quiz. All right? Thanks, guys. So thanks, guys, for watching today. I'm really grateful that you were able to get this information and get it all down and be ready to explore stuff on your own. So if you have any questions, be sure to ask me in class or email me. My email is on the syllabus on Canvas. You should have that down. But that's all I had for you. So thank you.